I am going to walk you through finding a quadratic and exponential regression using DeltaMath. It's very similar to what we did with the linear regression, just slightly different. When you guys start, make sure you're reading these questions here. So this is where all the information is coming from. And I know some of you had some trouble with rounding. So make sure that you're paying attention to what the directions are telling you. So company X tried selling widgets at various prices to see how much profit they would make. Well, let's pause there for a second. We learned that whenever we have an equation that talks about profit, we know that's going to be a parabola. So we're not looking for a line of best fit, we're looking for a quadratic of best fit or a parabola of best fit. So the table shows the selling price and then the profit for the company. So write a quadratic regression, rounding to the nearest hundredth. So that means 2 decimal places. And then use this equation to find the profit to the nearest dollar for selling at a price of $10.25. All right, so first thing we need to do is take care of the regression. So I'm going to copy the values for the calculator and then open the graphing calculator. Paste the values in right there. I'm going to go up to the top menu. We want to calculate. If you look here, this would be one variable statistics, which we don't have because we have x and y values. Linear regression is what we've done. We're going to look for a quadratic regression. And let's go ahead and turn our diagnostic on so you can see that correlation, that R value. And here we go. All right, so a couple things that are going to be different. First of all, we're not doing y equals mx plus b because we're doing the parabola of best fit. So this is standard form of a quadratic right here. Our A, our B, our C, and then we're only going to get an R squared with quadratics, and we get 0.9972, which is awesome. So we know that this is going to be a great fit when we get to see the graph. So right now I'm going to jot down these numbers. Just to remind us, we're supposed to be rounding to the nearest hundredth. So that means 2 decimal places. So I'm going to go right here. And if you think of it as money, this is going to be negative 5.79. So this 8 is going to cause this 8 to bump up to be 79 cents. I'm going to go right here for the value of B. We have 114.24 because that 5 is going to cause the 3 to bump up. And then we're going to look right here, and C has a value of negative 307.81. And that's because the 2 is not going to cause the 1 to round up. All right, so I think I've got my numbers down. So I'm going to go back over here. We always need to put y equals, always, always, always. So now you need to remember that we're doing standard form of a quadratic. So negative 5.79 is A, and then x. All right, to get the exponent, you need to press Shift 6, which is the caret button, which you hopefully recognize from our calculators, our scientific calculators. Then you need to arrow over, so you get off of the exponent. And then we need plus b, so 0.24x. So I have ax squared plus bx. And now I need plus c, which is a negative 307.81. All right, so I'm just going to scan this again. So 5.79 x squared, here's my b, and then my c. All right, so now using this equation, find the profit to the nearest dollar if the selling price is $10.25. So the selling price is the x. So I need to replace x in my equation with 10.25. All right, so grab your calculator and clear this off. All right, so I need negative. So remember the negative is under the 3. So negative 5.79. I like to use parentheses. So I'm going to say parentheses 10.25 squared, close the parentheses, plus 114.24, and then I need to fill in times 10.25 again, and then minus 307.81. I hit enter, and I got 254.838. All right, now this asks to round to the nearest dollar. So 254.8 would cause this to round up to $255 because it said nearest dollar. All right, so now I'm gonna click submit, and then I'm just gonna pause here for a second. It's worth it because since this is auto-graded, if it doesn't match exactly, then we are going to get it marked wrong. So I think that looks good. Click yes, I got the green check. But here's the thing. If you scroll down, this shows you everything that you should have done, including what the graph looks like. So you can see that it, in fact, is a quadratic. So this is what we got from our calculator. We rounded this way, filled in the equation, always put y equals, then we filled in the 10.25 for x, we got our answer, and we rounded it to the nearest dollar, and here is a graph. So this was our scatter plot. We got the curve of best fit here, looks fantastic. We can see why the R value was 0.997 or whatever it was. They don't have that up there for us anymore, but we can see, and then this is the point that we looked for, which was what the profit was if they priced their item at $10.25, which is pretty close to being their maximum profit. All right, so that is a quadratic regression. So I'm going to go over to this one and go ahead and close out that. And here is an exponential one, so let me get rid of that one. All right, so again, don't skip the information at the top. The accompanying table shows the value of a car over time that was purchased for $14,500. X is the years and Y is the value of car. Well, we've done enough questions to know that if whenever we talk about the value of a car, it's very likely going to be an exponential decay because the value of the car is decaying. All right, so write an exponential regression for this set of data. We are going to the nearest thousandth. Okay, so the way the decimals go, 1 decimal is tenth, then 2 decimals would be hundredth, 3 decimals is thousandth. So we need 3 decimal places. All right, using this equation, determine the value of the car to the nearest cent. So when we go to answer the question of how much the car is worth after 14 years, we want to go to the nearest penny, which would be 2 decimal places, which would be hundredth. All right, so we're going to copy the calculators, open the calculator, copy the values, sorry. Open the calculator, we're going to calculate. And again, we're doing exponential. So we've done linear, we've done quadratic. This is a natural log, which has to do with exponents. And then this is a power regression, which is also, that would be if we were looking for what the exponent was. But we know that the variable is what we're looking for right there. So we're doing an exponential regression. I'm going to turn the diagnostic on again so we can see the value of our R. All right, this looks great. So again, the equation's different because this time we're doing an exponential decay. So we have our starting amount, which according to our decay is $14,600. It's decaying about 17%, because this is going to be 0.82 or 830 if we want to think of it as 2 digits, but they did say 3. And then the R value, it's decay, so it's negative 9976. That's fantastic. All right, so I'm going to jot these numbers down. So for the value of A, we have 14,605, and we want 3 decimal places. So I'm going to go right here, and the very next number is a 3, which is not going to cause that 098 to change. All right, now we're going to go to the value of B, and B is 0.829. The very next number is a 0, which is not going to cause it to change. All right, now remember that our equation for an exponential is the starting amount times, this is going to be our decay amount here, and then to the x. All right, so I'm going to go back because I have the information I need. All right, go in the box. We always need y equals. All right, so first we have our starting amount, which was 14,605.098. And then in parentheses, 0.829, close the parentheses. Let me get that out of there. And then exponent, so that means shift 6, and then x. All right, so let me just make sure I copied that right. 14,605.098, and then 0.829 to the x. Okay, so now we need to calculate. So using this equation, we're looking for the value of the car after 14 years. So we know that the year is 14, which means we're filling in the x. So we need to grab our calculator, and then we're going to be doing our equation down here. So 14,605.098, parentheses, 0.829, parentheses, exponent is 14 for 14 years. And then this asked for the nearest penny. Okay, so I got 1,057 point. Okay, I got 469. So if we have 469, this 9 right here, because we want to go to the nearest penny, is going to cause this to become 47 cents. All right, click submit. This gives me just a second to, again, just double check, make sure I didn't type anything wrong, because it is auto-corrected, and then let's say yes, and we got it right. So again, if you go down here, we can see there's where we did our rounding. Here's our equation, which we did correct. And then here's the value of the car that's decaying over time. And after 14 years, we can see its value is just over $1,000. All right, so that shows you how to do both an exponential and a quadratic regression. Remember, pay attention to the storyline. That's a good review, and lets you know that if the value of a car is depreciating, chances are that's going to be exponential decay. If you get a question about a rocket going up in the air, chances are that's going to be a quadratic regression. So pay attention to what the question is telling you. And then, again, watch the rounding, and then make sure when you type it in that you're typing in exactly what you intend to be typing. All right, good luck.